Good afternoon, Algebra 2. Today we're talking about 8.2, inverses of relations. So these, I really like these. I think they're easy to understand, and they're very, very useful, as seen here in our first example. First, get down your definition. The inverse of a relation is the relation obtained by reversing the order of the coordinates of each ordered pair in the relation. Okay, so essentially, we're changing our inputs for outputs and our outputs for inputs. That's what we call an inverse. Okay, so for example, a really, really helpful and useful example of these is when you're converting money. Because we live in the USA. Let's say we're going to Canada. All right. So if we wanted to take our U.S. dollars to the exchange, the bank, or wherever they do it, and we wanted to say, okay, give me Canadian money. Well, if I took $10 in, they'd give me $15 in Canadian money. If I took $20 in, they'd give me $30 in Canadian money. So the function here is y equals every dollar that we give them, they give us, essentially this is 3 halves, but $1.50 back. Okay, which might seem exciting and be like, oh, why don't we just move to Canada because they have more money there? But everything's relative. Everything costs more there too. If you ever go near Canada or in Canada, you'll see a Canadian price and a U.S. price, and the Canadian price is always more because of their exchange rate. So, essentially if we brought them $50 of U.S. money, they'd give us $75 in Canadian. Now, if we take the inverse of this, so let's say, okay, we had a great time in Canada, we visited Niagara Falls and everything else there is to do, and now we're coming home. And let's say, we have $15 left. How much is that in U.S. money? Well, essentially, if it was 15, it's going to switch back to 10. So we basically just swapped our columns here. So if we give them $15 in Canadian money, they're going to give us $10 in American money, because our money is worth 2/3 the amount of what theirs is worth. Okay, so then if we have $75 in Canadian money left, then we would get $50 back. Okay, so essentially these are exact opposite of each other, which is what an inverse is. Alrighty, so let's take a look at our first example here. It says let f equal our set of points here. Now remember, when I have a function like this, the only thing I'm allowed to do is literally what they have in here. I'm only allowed to be 1, 4, or 2, 8, or 3, 8, or 0, 0, or -1, -4, okay? I can't be 2, 5, because 5's not in here. I can't be 17, -3, because neither of those are in here. I'm only restricted to these right here. So our first task for part A here is to find the inverse of f. Very easy. Now f inverse, I like to use the symbol of the -1. And if you remember from matrices, we used to have, I'm going to write this in the corner, a of -1, which meant take the matrix A and do the inverse. That's what this little symbol stands for. So this is your inverse. Okay. So that's your inverse. So we're going to use the same thing here. So we just have f of -1, which is the inverse of f here. And essentially all we're going to do is we're going to switch all of our inputs for outputs and vice versa. So this 1 and this 4 are going to switch places. So here we go. We have 4, 1 then. So our first ordered pair is 4, 1. Our second ordered pair, we just switch these. We have 8, 2. Our third ordered pair would be 8, 3. Our fourth ordered pair, well, switching 0, 0 doesn't do anything. It's still 0, 0. And then finally we have -4, -1 for our last ordered pair. So there's the inverse of f. We just switched everything, and that's really all it is. Now we got to find the domain and the range of f and its inverse. So f would be the domain here. So domain is going to be, now remember, when you do these, you just write them as a set again. Don't try to figure out, oh, is this positive real numbers, negative real numbers, bigger than 0, etc., etc. You literally just list. Domain, remember, is input. So we have 1, 2, 3, 0, and -1. So we just take all of those and list them out. So 1, 2, 3, 0, and -1 is our domain. For the original function, remember, we're doing f first. The range for my original function is going to be all my outputs. So 4, 8, 8, 0, and -4. So let's list those. So 4, 8, 8, 0, and -4. Okay. Now when we do the inverse, so essentially we just switched everything. We could look at these here and, circle and box them and such, but for my domain, what was my domain is going to be my range, and what was my range is now going to be my domain. We essentially just switched. And if I look at my inputs up here, I have 4, 8, 8, 0, negative 4, which is exactly what my range was for my original function. So I'm just going to list that out now as my domain. So 4, 8, 8, 0, negative 4 is now my domain of my inverse, because we're just doing the opposite. That's what an inverse is. So now my range was going to be the domain originally. So 1, 2, 3, 0, negative 1, which is exactly what we had here for our domain. So 1, 2, 3, 0, negative 1. So notice they just flip-flopped. Okay, that's supposed to happen. Okay, and task C here says to graph the ordered pairs of f and its inverse. Okay, so we're actually going to take f, and I'm going to do that one in red here. And I got my highlighter out just because these don't graph very well with the pen, so I'm going to do nice big dots. Go ahead and graph along with me, because of course you should be doing all the examples. We're going to see something that's actually kind of cool here that happens. All right, so let's plot f first, which is the points 1, 4, and then 1, 2, 3, 4. So there's our first point right here. Oh, gosh, golly. Stop doing that. Sorry, I don't know why that pops up like that. Drives me crazy. There we go. Okay, I guess my points will be more like lines than anything. Alrighty, so there's our first point. Our second point will be 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, then 3, 8, so 1, 2, 3, and then up to 8. I don't know how to get it to stop doing that. Otherwise, I would. Okay, there we go. 0, 0, that one's easy enough. Right there. There we go. And negative 1, negative 4. So back 1 and then down 4. Okay, there we go. Alright, there's our points or lines or however you want to call them. Alright, now we got to go graph its inverse. So let me get a different color here for you. Let's do green. Make it a little Christmassy. And now I'm going to do these points right here. Sorry, I just like colored over my F inverse, but we're doing these because it's the inverse. So 4, 1 is our first point. So 1, 2, 3, 4, 1 is right here. And then we have 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2 is right here. Alrighty. And then we have 8, 3. So out 8 and then up to 3 then is right here. And then 0, 0. Oh. That's one we know and love. And negative 4, 1, 2, 3, 4, negative 1, which is right here. Alrighty, so there we have it. There's our points. Now, the interesting thing I want you to recognize here, and let me get yet another color. Let's do like a yellow. Okay. Is these actually, if you look at them, and I'm going to draw this line in here as best as I can. Okay, pretend it's straight. Okay, that's not bad. If I drew that line in here, this is actually the line y equals x, okay? It has a 0 as its y-intercept, and then its slope is up 1 over 1, up 1 over 1, up 1 over 1, which is y equals 1x plus 0. So this is the line y equals x, and this is our parent linear function here. And what, if you notice, if I take this red dot here and reflect it over this line, I end up right on this green dot. If I take this red dot here and reflect it over this line, I end up exactly here. Same for this one over here. It's as if I'm folding this coordinate plane in half, and this is landing right on top of this green point. Obviously, these two are going to land on top of each other because they already are, and notice the point goes right through this line. And then this one, now we're backwards though, because we started out with a green landing on top of a red, but still, it's the same thing. They should reflect upon one another. Meaning if I fold my piece of paper along this line, these should land on top of these. And you can try it. Since you guys actually have a piece of paper, it will fold over. They should be exact if you've drawn everything to scale here. So this is not unique to this function. This should happen every single time you have an inverse. It should reflect, and we're going to go ahead and jot this down here, reflect along the line y equals x. Okay, I'm sorry, I know that's a little hard to see here, but that's will always happen for any function. We're always going to be able to fold this piece of paper and land, you know, one piece will land on top of the other. Alrighty, we're going to talk a little bit more about this phenomenon in the next video, so please hang tight, download the next video, and I'll see you in a second.